Question 13a. A 2-meter high sculpture is to be made out of concrete. The sculpture is to be formed by rotating the region between y equals x squared plus 1, and y equals 2 around the y-axis. Find the volume of concrete needed to make the sculpture. The sculpture is a composite solid, formed by rotating the curve y equals x squared about the y-axis from y equals 0 to y equals 2, and subtracting from that the volume formed by rotating the curve y equals x squared plus 1 about the y-axis from y equals 1 to y equals 2. And that's the hollow formed in the sculpture. The volume V of the sculpture is given by the volume of the outer curve minus the volume of the inner curve. So that's pi multiplied by the integral from y equals 0 to y equals 2 of x squared dy minus pi multiplied by the integral from y equals 1 to y equals 2 of x squared dy. So this x squared here refers to the outer curve and this x squared refers to the inner curve. Now note that y equals x squared. We need this in terms of y. Hence x squared equals y. And for the inner curve, y equals x squared plus 1, and making x squared the subject of the formula, we have x squared is equal to y minus 1. So the integral becomes pi multiplied by the integral from y equals 0 to y equals 2 of y dy minus pi multiplied by the integral from y equals 1 to y equals 2 of y minus 1 dy. And that equals pi multiplied by y squared over 2 from y equals 0 to y equals 2 minus pi multiplied by y squared over 2 minus y from y equals 1 to y equals 2. Applying the limits of integration, we have pi multiplied by 2 squared over 2 minus 0 minus pi multiplied by 2 squared over 2 minus 2 in brackets minus 1 squared over 2 minus 1 in brackets. And that evaluates to 2 pi minus pi over 2, which equals to 3 pi over 2 cubic meters.